So as I mentioned this morning, in the second half of the day, we're going to be zooming in a bit more on applications of microgrids in developing economy contexts. So we have a two-part technical session. We're going to have a break between them. But in the first part, we'll talk more about existing project success stories and field stories from the developing world. And then we'll talk a little bit more about really what's at stake for improved energy access. Just how can energy access improve the lives of billions of people in the world, and what role can microgrids play? Before we get into the technical session, though, I'm really pleased to introduce our next speaker, Dr. Hannah Daly from the International Energy Agency, who's going to give our scene-setting presentation. So for those of you who aren't familiar with the International Energy Agency, it's an autonomous agency that's been set up by member country governments. It's been around for about 40 years, and one of its primary roles is providing policy and energy market guidance to member countries. So Hannah is the lead energy access analyst, and she also works for the World Energy Outlook team, which produces the annual World Energy Outlook, which is really one of the gold standard publications globally for energy markets and technology trends and policy analysis. So with that, I'll turn the floor over to Hannah, and we'll also have a few minutes after Hannah's talk for Q&A from the floor. Okay, take it away, Hannah.
Thank you so much. Thank you for coming back from lunch, and please bear with me while you struggle to understand my Irish accent and struggle to hear me through my cold. So with those challenges, I hope this will be an interesting presentation for you. I've learned so much this morning about the kind of technical work of microgrids, how they have been developed, and fundamental research improving them. And I'm going to take you on a different trajectory with this presentation. As Eric mentioned, the World Energy Outlook is the kind of one of the global flagship gold standard publications for energy analysis and policy projections and advice. But for almost 2 decades, also the World Energy Outlook has consistently looked at energy access as a fundamental global issue. And last year, in 2017, for the 2017 World Energy Outlook series, we published a special report looking in depth at energy access issues, which was the most in-depth report we've done in many years on the topic. And why did we do that? So in 2015, 193 countries of the United Nations ratified the Sustainable Development Goals. These were an evolution of the Millennium Development Goals, which I think were more widespread in the public conscious. But the Sustainable Development Goals presented a few evolutions on the MDGs for a few reasons. Firstly, it includes an explicit goal on energy for the first time. Energy was recognized as this golden thread that weaves together human economic growth, human development, and sustainability. And it was recognized as a fundamental input to reaching many of the other SDGs, which I'll go on. One of the other developments of the Sustainable Development Goals was that it seeks to address both developing and developed countries. So not just looking at developed countries. And thirdly, it recognizes that all the SDGs, all of the development goals are interdependent, that you can't just look at one in isolation, and you need to really have a holistic view about development. So what this report finds is that despite this objective to reach universal energy access by 2030, still 1.1 billion people don't have access to electricity today. And 2.8 billion people don't have access to clean cooking. What does it mean to not have access to clean cooking? It means that the household has primary reliance on a fuel that is not considered clean, which is either fuel wood, coal, or kerosene. And what are the effects of that? We find that women, for example, women and children, bear very much the burden of this lack of energy access. In many countries, women and children spend over 5 hours each day gathering wood, cooking on polluting stoves, and those stoves are linked to around 2.8 million premature deaths per year. Outdoor air pollution seems to be a more kind of visible health burden, but indoor air pollution is also a killer. To put that number in perspective, 2.8 million people is twice the number of deaths from AIDS and malaria combined each year. But since the adoption of the Sustainable Development Goals and the new political momentum that's come about since then, we see also technological promise. There's the declining cost of renewables, momentum in off-grid decentralized systems, end-use efficiency has really become more affordable and widespread, and new digital technologies which are tracking energy use are really transforming the energy access landscape and potentially opening this new door for decentralized renewable access to rural areas where that was not possible. So the purpose of this report has been to look at whether this new political momentum, whether this new technological process is enough to bring universal access to energy, whether current policies and current trends will bring us there, and if not, how do we fill the gap, what policies are needed, what investment is needed. So first I'll take you on the historical, tell you what the historical data says. There has been sustained progress in electricity access since 2000. Globally, there's been 1.2 billion people gained electricity access since 2000, and India has led that progress. So 500 million people have gained access to electricity since 2000, and that number is, their progress is in fact accelerating each year with political momentum. This has been backed very much by investment. Other countries in Asia are similarly doing very, very well in access to electricity. Bangladesh, Indonesia, adding 100 million people with access since 2000. Other countries doing similarly. But it's really Sub-Saharan Africa which is being left behind. And now, in fact, there are around 600 million people without electricity access, which is more than there were at the turn of the last millennium. We were, if you can see there, there are some signs of peaking, and that we can see for the first time some sign of promise in Sub-Saharan Africa, with the number going down each year subsequently since 2013. Looking forward, looking at how current investments and policies look ahead, India is in fact on track to achieving universal electricity access by 2025, when around the time that the government commits this. This will be a really tremendous achievement, and the Modi government has put huge emphasis on that. Other countries in Sub-Saharan Africa are also on track, Indonesia, for example, and this is through a mixture of different types of developments. However, Sub-Saharan Africa, when you project forward individual country progress, because the progress has been so uneven and population growth still is projected to be very strong in many countries where progress is limited, we see a leveling off in the number of people without access. We've also, for the first time in this report, done a really in-depth historical analysis of where that electricity access has come from, and these are the results. Coal has contributed to 45% of new electricity access since 2000. In India alone, the number is three quarters, 75%, with gas and other fuels, meaning that fossil fuels in total have made up about 70% of new electricity access connections since 2000. However, in the past number of years, that number is starting to shift. And in Africa, Sub-Saharan Africa, since you've seen that acceleration in electricity access, there's actually been, that acceleration has been driven by renewables, especially hydro and geothermal in East Africa. We've done this analysis going forward, looking at where new electricity access will come from in the future, backed by geospatial analysis that I'll go to in the future. And as you can see, all different fuels are likely to make a change. But really, we see that the declining cost of renewables, innovative off-grid business models are really transforming the way that access is delivered, especially in rural areas. Those renewables will continue to come from the grid, but also will come from decentralized sources such as mini-grids and off-grid solar home systems. I talk about off-grid and solar home systems, and this kind of gives you a picture of what our report and what the IEA sees as maybe the definition of different types of access. We make the distinction between pico-solar, which we kind of is below the threshold of what we consider electricity access, which are standalone kind of appliances with individual little solar panels to power them, like solar lanterns. There's off-grid solar home systems, which are, a solar panel just for an isolated house that serves one particular house. And then there's mini-grid systems, which we're talking more about, that serve a community. And we see as energy development and energy demand grows, and this is obviously not such a linear picture as you see here, the impetus goes more towards grid development. And what are the different aspects of energy demand, electricity demand, that determines what is the best solution? One is the density of electricity demand. And you must remember that people in developing countries have a very low kilowatt hour consumption. They maybe have a few light bulbs, maybe they have a TV. And so the actual kilowatt hour demand of these people is very, very low, and it may not justify a grid extension being built out. It might be better just to have a very small solar home system. So really it depends. You need to know both what the density of the demand is within a particular area. You need to know how far away it is from a particular grid, and you need to know the cost dynamics, so the cost dynamics of solar and so on. One of the things that this graph also shows is that efficient appliances really brings down it makes off-grid and mini-grid applications a lot more affordable for people. The regulatory environment is also very important for whether mini-grids will be successful. So to bring you some of our results from this geospatial analysis that we did to take all those factors into account, looking specifically at the case of Indonesia, you can really see that there's no one-size-fits-all solution for bringing universal electricity access. It depends on the infrastructure, the geography, the density of demand, as I said. And this slide gives two examples from Indonesia. In Papua, it's an isolated low population density region in Indonesia. It has around 48% electrification rate, and it is a very good candidate for mini and off-grid technologies, mostly solar and hydro, and is the least solar and hydro technologies are the least cost option for around 3/4 of the people gaining access there, with even small-scale LNG hubs potentially providing electricity for the source of power for more densely populated areas. In East Java, in Indonesia, where there's 40 times the population density, recently around 225 villages have been connected to the power grid, and they were on average only 13 kilometers from the existing grid. So the bulk of new electricity connections recently was with the centralized grid, with the more remote villages being more likely to be off-grid and given off-grid and mini-grid electrification. So you have two lessons here. First of all is that both grid and decentralized systems have a role to play. It depends very much on the geography and on the population density and lifestyles of the people. And that the falling cost of decentralized renewables is really making a big impact. We've also mapped out a case for how to achieve universal access for all by 2030, because as you saw in one of the earlier slides, under our central case with current policies, still 600 million people would be without electricity access in sub-Saharan Africa. And this is a recent satellite image of sub-Saharan Africa. As you see, the continent, despite having a huge population, is almost completely in the dark. And we have done geospatial analysis to look at where the people are, and this is what the map would look like. Now, every time the IEA Twitter account puts this picture out, we get about 3 or 4 comments talking about light pollution, and I can see the point, but I hope you get the message that basically all of those light points there are currently in the dark completely, and this completely prevents sub-Saharan Africa from meeting its development goals. So this geospatial analysis is based on 1 kilometer by 1 kilometer square information about what we know about the population density of sub-Saharan Africa, what we estimate the electricity demand to be, what the infrastructure is, what the planned rollout of the grid is. And what we find is that the least cost solution for delivering universal electricity access, in this case, of those 600 million people who would be left out, grid access accounts for around 150 million, 1/4 of the additional people gaining access, with hydro accounting for the lion's share. But decentralized solutions, mainly solar PV, and more than half of that is mini-grid systems for the remaining 450 million people living in rural areas. Since we're speaking about mini-grids, I must say that for our new policy scenario, for our central case, mini-grids have a relatively very low role to play because we assume that the density of power demand is very low because the access rate grows slowly. But when you bring the power demand in every village up, when every house wants power, in that case, this makes the business case for mini-grids. The cost of that amounts to around $26 billion per year in extra electricity generation and grids. And the bulk of that accounts for the deployment of decentralized solutions. Now, I know that we're at a symposium on electricity access and development, but I also wanted to include a slide on clean cooking because it's something that both the development community and the academic community often neglect to discuss when they talk about energy access. Often come to these places and energy access is seen as synonymous with electricity access. But I really want to highlight that today, 2.7 billion people are without access to clean cooking. And that number is the same as it was in 2000, which is a really shocking fact when you think that the number of people living in poverty has come down, child mortality has come down so much. And this has huge consequences both for environmentally, in terms of environmental destruction. The charcoal industry has a hugely negative impact. The health consequences of that, which I talked to you about before. And for women's involvement in productive life and women's equality, because if you have to spend all of your time gathering fuel wood and tending a fire, then how are you going to be educated or work productively in the economy? We estimate that 300 million people would gain access to clean cooking in the new policy scenario based on current trends, and that's mainly in developing countries in Asia, where there is some progress being made in the rollout of LPG, especially in India and China. But in 2030, to give clean cooking for all, what you need is a big pie of solutions, depending on the context. Again, LPG is very useful in cities, gas in cities in Asia, electricity and biomass, improve biomass cook stoves, where you can't get more modern technologies. Now, just to wrap that up, we look at where we're going. We look at what the additional effort is needed to get to universal access by 2030. What is the additional cost and what are the benefits? The increase in global energy investment to deliver energy for all amounts to around $31 billion per year. Mainly that is in electricity in Sub-Saharan Africa. Just to put that into context, last year we invested around $300 billion in renewables. So for 1/10 of what was invested last year in renewables globally, you could get electricity or energy for all. And for that, you get a 0% net increase in greenhouse gas emissions. So delivering this has no net, is basically not in conflict with climate goals. And we're really pushing this message out to the climate community, especially for the clean cooking side. The current dependence on biomass for cooking is not climate neutral. It has a quite severe greenhouse gas emission consequences, and LPG, even though fossil fuel has a net climate benefit. And that benefit offsets any additional fossil fuels from electricity access. For that, you get 2 months of work saved per household. Just to put that in context, if you add that up with the number of people gaining clean cooking access, 2.3 billion people, 2 months of work saved per woman, a couple of hours a day, this amounts to around half of the workforce of the US, which is a massive incentive to increase the productivity. And you get 1.8 million deaths avoided annually from indoor air pollution, which is a massive health consequence. So in conclusion, obviously energy for all is really at the heart of the Sustainable Development Goals, and it's essential for improving livelihoods, gender equality, health, education, and all these different things. Policy is really needed. And first of all, policy needs to put access at the top of the political agenda. This is now becoming the case for electricity access, where many countries have put high-profile targets for electricity access, but the same needs to be done for cooking. And policy should enable a wide range of solutions and welcome the private sector. In many cases where the private sector can deliver solutions, it doesn't because the policy environment is not suitable. Those enabling policies especially need to target the off-grid sector and mini-grid sectors which offer great promise for rural electrification, but often when there are taxes on solar panels, where the pricing for mini-grid tariffs is not favorable, and so on, then private companies are put off going into a new economy. Energy efficiency should be at the heart of electrification solutions because it really brings down the cost of delivering access to households, but that requires financing solutions. And something I didn't get into, but providing modern energy for productive uses is essential to really address all development goals. Because you can provide a light bulb, you can provide a television, which has great benefits, but what you really need to do is to provide energy that will stimulate economic growth, jobs, and people's livelihoods. And therefore, providing electricity for productive uses brings down the cost also of providing electricity to households and improves the local economy. So we need to look beyond households. A big point is that universal clean cooking access won't be achieved unless it's elevated on the political agenda. And energy access and climate goals are not in conflict. At the IEA, we're really committed to continue to lead this in providing data, country-by-country data, policy guidance to support governments and the international community. This year we're playing a very big role in the UN's high-level political review of SDG 7 in July. Our executive director will address the UN on April 15th and introduce a series of policy briefs and summary for policymakers that we've done with a number of different organizations. And finally, I encourage you to download the report. I have a number of hard copies here. If anyone would like to have one, I don't want to take them back to Paris with me. But you can download the report as a free PDF. You can explore the data behind the report, country-by-country data going back to 2000 for electricity and clean cooking access. And I was very happy to see Eric this morning take screenshots of our new data portal on the SDGs. So we have historical data and projections from the World Energy Outlook from our data for all of the SDG 7 indicators. So I really welcome you to download that. And if you have any questions, please come to me or email. Thank you very much.
So we certainly have time for a few questions. Yeah, please, Christina. And do we have the mics going around?
I can, yeah.
Okay, if you speak up, we should.
So you mentioned the notion that there's a lot of the demand has been met by hydro, which is also, certainly seen that in Ethiopia, that's true in East Africa. So in some of my discussions there, when I asked about, solar and wind, where there's a lot of resource there as well, the resource base is great, the comment I got back was, well, hydro is basically subsidized because that's being paid for by the government, and then it's just the transmission. Whereas it's very hard to compete as a private company to come in and start selling solar panels or installing, wind farms and so on, because you just don't have that benefit. So what's your view on that?
Well, in many cases as well, the government sees private companies come in selling solar panels, and they see a profit, and then they'll slap a tax on solar. So even it's not subsidized, it's there's a tariff put on. So I mean, we very much agree that there should be a level playing field between the different fuels, and the governments really need to be supported with energy planning, energy modeling, and analysis to be able to kind of understand these dynamics, because hydro has a role to play, but so does solar and all these different solutions. So. The view is that governments need to be supported to understand these dynamics, where often energy planning is almost absent in these countries. So.
If I may, following up on that question, I also come from a part of the world where hydro is heavily used. And one thing about hydro is, in a sense, renewable, but it is also a form of energy production that has impact in the environment.
Yeah.
I was born just 100 miles away from the largest hydropower plant in the world. brings me to the following question. We are talking about the change in the technology of the power grid. And I see very little discussion about the change in the technology of generating energy from hydro, which seems important, particularly when we think about production from hydro in areas like Amazon, where it's highly undesirable to create lakes. Would you be able to comment about, for example, prospects of generation from continuous streams or are there other ways to utilize hydropower while minimizing environmental impact?
I mean, there are certainly demonstrable ways to deploy hydro in an environmentally sensitive way. And of course, we support that all governments do that. I mean, in our projections, we don't necessarily take a value judgment about the different fuel sources. We look at policies and current investments and where that is likely to take countries. So it's kind of a fuel neutral approach, if you know what I mean. But as for the deployment of hydro, we see it as one of the currently one of the main renewable sources of fuel. But going forward, solar and wind are accelerating so much that they will lead electricity generation, renewable electricity generation in the future.
So you don't see hydro being innovative, you see it replace that by other technologies?
I'm sorry, I missed that.
You don't see innovations on the hydro electric generation, it seems that will be replaced by other ones.
Not necessarily. We're still seeing growth in hydro. The absolute amount of hydro, more the fact that wind and solar are accelerating so quickly that they will become a significant share of renewable electricity generation going forward. And there are certainly best practices to be followed in the deployment of hydro, which I wouldn't comment on further.
Hello, my name is Janet, and you talk a lot about solar and wind and so on. Can you talk a little bit about how those industries are growing as local industries, so not just the impact on the consumer, but actually growing businesses in Africa?
So there are, thanks for your question. We estimate that kind of off-grid solar home system companies right now have a very small impact in absolute terms. Around 33 million people, we estimate, have access to electricity with off-grid systems at the moment. Most of that would be, around half of that is in Asia, mini-grid systems in Nepal, off-grid solar home systems in Bangladesh are very strong, which is supported by the government and subsidies. In sub-Saharan Africa, though, there is a huge acceleration in these off-grid solar home system companies. I'm sure many of you have heard about Mcopa, Mobisol, Off-Grid Electric, and these companies are extremely innovative in that they're coupling small solar panels with efficient appliances and mobile payment techniques.
Are they actually making the solar panels there?
No, they're not. I mean, in terms of manufacturing capacity for solar panels in sub-Saharan Africa is quite low.
Actually, any of the places that you're talking about here, is there any local manufacturing?
There would be significant local employment in selling and distributing the solar home systems, but often these companies are based in Europe or the US, and they're providing electricity access. They're making profit from these very poor people, but making a very significant impact. As to where the solar panels are manufactured, I'm not sure what the stream is. I think, as far as I believe, they're imported mainly. Yeah.
So maybe is there one final question, a brief one? If not, I may take it while our next panel sets up. So, well, first of all, thank you for a very interesting presentation. Really.
Thank you.
Really heartening to see that pathways do exist and that there's so much to gain if we are to pursue those pathways. So it's striking to me to see just how much progress India has made over the last 15, 16 years, and that they'll be really at a point where they have universal electricity access by 2025. Okay, recognizing that sub-Saharan Africa is a collection of 45 different countries, if they were to do what India does, how would they do it? What would explain India's success that other countries could replicate ideally?
India is a little bit different from sub-Saharan Africa for a number of reasons. First of all, there's a single government that can make a high-level commitment and kind of mobilize this resource and this investment. It also has much greater population density than sub-Saharan Africa, so it can roll out the grid in a much faster way. It electrifies villages, and for the last 10-15%, it's aiming to provide solar home systems for the kind of villages far from the grid. So it basically has a huge capacity for energy planning. It can make this pathway. It can kind of mobilize that investment. As I said, 99% of the electricity access previously came from the grid. We estimate that to change slightly going forward, and more come from renewables, both grid and off-grid. But it would be individual countries within sub-Saharan Africa can take that path, but as a whole continent, that's where the problem is. Thank you.
So we'll just take a moment to set up our third panel session.
Great. So, perfect. So, we're going to talk more about developing context, and Hannah gave us a great introduction to the developing context. And we're going to basically hear. I think they can hear me, but yes, great. So we're going to hear from three experts on how microgrids might look like or are already looking like in a developing context. So we'll have first Taneja talking about his experience developing microgrids. Then we'll hear some more from Craig about tonnage farm. And we particularly wanted Craig to be also in this panel because we wanted to think about how renewable microgrids might look like in developing context. This is kind of a high bar, but we'll explore in the panel whether that's a possibility going forward. And then we'll also have Bijay talking about his own, Bijay Modi talking about his own experiences. So this is a very hands-on panel. Everyone here has great experiences, hopefully great experiences in the microgrid setting. So we're gonna basically ask them a lot of details. Before I ask them a lot of details, or you ask them a lot of details, we'll let them give us a 5-minute, 8-minute introduction on again, their own microgrid experiences, starting with Jay. Thank you, Jay.
Great. Thank you, Mar. So thanks for organizing this event. Is the mic on? Sounds like it. So I have a few slides I can just briefly share. So why am I talking about Sub-Saharan Africa, but I'm a professor in Massachusetts? I was actually at IBM Research in Nairobi for a few years prior to going to Massachusetts, so this tends to be the highlight of my work. So I want to share a little bit about microgrids in East Africa and some of the challenges and open questions particularly. So I'll start with just a kind of a laundry list of questions and then a little bit of data and kind of some background on what characterizes these questions. So first, very, very big challenge when it comes to microgrids is siting, and particularly finding those sites that kind of solve the Goldilocks problem. The Goldilocks problem with microgrids is essentially that you need to have enough density, you need to have enough electricity demand in an area, but at the same time, if you have too much density, then the grid tends to come to that place. And so you need to find those sites that kind of fit in between. If you tend to not have enough density, but there's enough income and enough consumers in the area, then maybe it's a better site for a solar home system. So finding those kind of intermediate sites that work can be part of the challenge, and this has stifled a lot of growth in East Africa, where I spent a lot of my time and studying of the microgrid problem. Second is some policy questions. So this has been mentioned a few times already today, but particularly we're thinking about interconnections with the grid. We're thinking about engineering standards. So how large should each connection to the house be? Or do we need multiple kilowatts, or is 1 kilowatt fine? Things like that. And then tariffs. So particularly there's some challenges in certain countries where the electricity regulator will dictate that it must be a national tariff. And that essentially is a non-starter for many microgrid models because the recovery of CapEx is such a high burden that the cost for each unit of electricity must be higher than what the kind of grid amortized model can actually accomplish over a national grid. So this tends to be kind of a non-starter. So these three sort of policy questions dictate a lot of, I think, where microgrid policy is quite a bit undefined in many countries, and different countries have varying levels of progress in these areas, but they're still fairly open questions. Third is really thinking about demand. So if we're thinking about mini-grids or microgrids as a growing and developing area, we need to think about how we can get private capital to that area. And particularly, to get private capital there, you have a profit motive. And that profit motive has to have enough product to sell, and they have to have enough consumers to purchase that product. And I think this tends to be a big problem with microgrids is that while there might be enough identified customers, those customers don't necessarily purchase enough electricity to sustain that business. And so I have a little bit of data on this that I can share. And then last is a question I actually asked earlier, which is about ownership models and operation models. So you see a whole variety of different models at this point. You see sometimes it's NGOs owning and operating. Sometimes it's local operation and a large capital influx coming from investors or private operators, things like that. You see a kind of a melange here that really hasn't been worked out. And I'm not sure it's necessarily going to be one dominant model, but I do expect that there will be a small number of dominant models. Those haven't necessarily emerged at scale yet. So thinking about the question of demand, how much is consumption on mini-grids and how does this stack up? So this is some work from a colleague at Carnegie Mellon, Paulina Jaramillo, and her postdoc now, Nathan Williams, who I've worked with for a number of years. They work with PowerGen, which is PowerGen Renewables, which is a mini-grid operator across East Africa. They have about 30 microgrids now. I say mini-grid, microgrid. This is something that Chris alluded to earlier. There's a lot of challenges with definitions here. So assume those are relatively interchangeable. So what I have here, this is a study on 11 of PowerGen's grids, and these are all solar battery grids. So these are all fully renewable microgrids. These are in Kenya and Tanzania, so those are the codes here on the left. And what we're seeing is the monthly kilowatt hours per customer. So monthly kilowatt hours, I have in the bottom left here, we've got a mean of around 7 kilowatt hours and a median around 2.5 kilowatt hours per customer. So to give some context, this is, US number is probably, around 700 or so per month. So we're in a household, so we're looking at a fraction of this, and this is a mix of residential and commercial customers. Now, important to note, these customers are paying a much higher rate of a tariff. They're paying $1 to $2 per kilowatt hour. This is relatively standard for mini-grid models in East Africa, and it's obviously price higher, demand is going to be lower. Exploring that range is actually pretty important, but these are the kind of models that are dominant in these kinds of grids across East Africa. So, we have a challenge here where we have, this is data on how that demand has developed over time. So we can see on our x-axis here is months since connection. It's a mess, but the important thing to realize is that we've got low consumption and we have, unfortunately, anemic growth. People aren't necessarily adopting new appliances. They aren't necessarily growing consumption. And it shows that this is the product that these electricity service companies are selling, and they're not selling enough of it. And it's a huge challenge for a lot of these companies to sustain and be functional businesses. At the same time, we see very similar patterns on the grid. So I have some joint work with Vijay that looks at how the electricity consumption growth has developed in Sub-Saharan in Kenya specifically, and we see a lot of similar patterns. It's maybe an order of magnitude higher, so roughly 20 kilowatt hours a month, but still that's not enough to even sustain a grid model in many cases. So that all said, what can we do about that? The big challenge here is that there isn't enough growth in demand. We're not seeing enough of that product for these electricity service companies being sold. And so as part of this, we're conducting a couple of pieces of work. So we're conducting an appliance financing pilot. And the real question here is, does providing financing for appliances enable increases and durable increases, ones that can stick around past just that initial growth in electricity consumption? Can we get more of that product selling? So we're working with a set of developers in East Africa. This is 4 developers ranging from developers that have 1 mini-grid to developers that have 30 mini-grids. And this is in the field right now. So thus far we've conducted this offer to 2,100 customers. And at this point, about 16% of those customers have actually opted in. So what are these appliances? Well, TVs, cold storage, those are about 1/3 of the set of appliances each. A lot of subwoofers and speakers and things like that. But the question here is, can these appliances lead to durable consumption growth and also business growth? So we'll be surveying a lot of these businesses as well. So this is a mix of businesses and residential customers, but we really want to see, can these customers pay back for these appliances, and will that consumption stick around after the term of this loan is over, and will that be able to help sustain these businesses? So this is work in progress, but we're really trying to get at some of those questions around productive uses. So the next step around here, I mentioned earlier that the current tariffs that are paid for by these customers are generally $1 to $2 per kilowatt hour. What about the space between the 15 to 20 cents per kilowatt hour being paid on the grid and the $1 to $2 per kilowatt hour being paid on microgrids? Exploring that space in between and really understanding, how does demand change as that price of electricity changes? So we're actually exploring that by working on a tariff subsidy. So this is work that's funded by the Rockefeller Foundation to really understand that middle space between where mini-grid prices are now and where grid prices are now. So last, I want to wax poetic a little bit. We're in Chicago. So this is the home of the electric utility business model. And Samuel Insull, who was Thomas Edison's secretary and came and started Chicago, really took Chicago Edison and made it into what is the model utility of today's industry. Well, he actually solved some of these same problems. He looked at how we were able to grow consumption in that world, and really the answer was that he figured out that AC grids were the way. He got away from the small DC loops. He pushed appliances. He really wanted to get these appliances out. They ran all sorts of interesting ads and trying to change behavioral patterns of saying, well, how do we eventually get building layouts to be different? How do we work in appliances into the fabric of people's lives and really changing how people use electricity? This was hugely beneficial to increasing load factor. This made the utilities actually work, that they could have loads during the day as well as loads during the night. And he also dropped costs immensely. So Samuel Insull was not charging $1 to $2 per kilowatt hour. He was charging 8 cents a kilowatt hour, which was expensive then, but it was a huge factor below what utilities were charging prior to this, what DC utilities were charging, and really it defined the modern utility model. So this is sort of a call to say, can we do the same thing in a mini-grid model? Is this the way that we can unlock that demand? It's not necessarily certain, but it's a good thought piece and something to think about. So that's all I have. Thanks.
Yeah, but I think I've already showed a whole bunch of slides, so I think I want to talk about and go with Jay up one level. So we're involved in a couple of two projects and some think tank work around this concept. So going up from the micro mini grid and up one level. So we're working with a group in Taiwan on it's about a 500-acre farm, has a hotel, has a restaurant, seasonal application, huge hydro reserve on the east coast of Taiwan, virtually no wind, good solar for the first part of the day, and then they're up against a mountain, so nothing on western sun. So what are the limiting factors in trying to design a microgrid around something like this? Well, first of all, they're actually connected to the grid. So the first step is, where are you using energy? And this is a puzzle that we in the microgrid industry have not really got our heads around yet. Because the only way to know that is getting more granular metering information. And actually, where are the smoking guns? Where are the large loads? So we actually had a startup at Stone Edge Farm that was extremely innovative project called the Power Patch. So envision a gluey patch that you stick on a circuit breaker, and it is capable of recording the current through that breaker. Well, now I can, data log a building without having to open the panel up, pry the wires apart, put it on a toroidal transformer, and then go away for 30 days or 60 days, come back, take all that infrastructure apart. You just simply walk up and stick the dot on, connect a ribbon cable, and boom, you're done. Well, that company unfortunately went into the valley of death and died, and a competitor immediately bought the IP and shelved it. So right now we don't have a solution on the market for going in and collecting data. So we had done quite a bit of work with TED devices, and they're a company out of Connecticut, I believe. So we had, 25, 30 TED devices laying around. So we shipped those to Taiwan and trained a group of people who were going over to Taiwan to institute those, and we actually just got the report back. Well, now we have enough granular information, and fortunately, nobody got electrocuted doing the data logging, which is always a good part of it. And now we can actually get down to designing systems for it. So kind of the same problems up one level. And then we had been working around India. And we've had 4 interns from India in our program. And they were from all different schools all over the country. They all master's degrees, all here in the States, got their masters. So one of the things we were working on as a think tank perspective is, what do you do in rural India where you're beyond the grid and yet you have a fairly high population density in a small area? So we came up with a containerized solution, which there's multiple containerized solutions out in the world. But one of the things the interns came up with I thought was kind of interesting. If everybody knows what a DeWalt battery is that you put into a drill motor and goes woo woo, so you can drill holes or shoot screws in. They came up with a concept of the container having a whole group of these batteries on the side of it. And then the individual homeowners could come to the central location where solar was deployed, take a battery out, stick their old battery in from the day before and go home, which would give them lights, if nothing else. And then they did extrapolate on that to, could we run a small refrigerator? And then they talked about the fact that in rural India, there are places you can't drive an ISO container, a shipping container to. So they actually came up with a system that you could hand carry in with a group of people, set it up, set the solar panels up, and have it operate. And of course, whenever we say solar, wind follows suit to that if there's a wind resource. Wind is a whole nother animal for controlling. If you have it, it gets more interesting. And of course, these would have very simplified control systems. But extrapolating off of this, I want to talk about something, and I can't take credit for this. Catherine von Borg, who's the CEO of Simplified Power, came up with a concept. So right now in lowering these costs, and particularly as we start to think about the third world, China is doing huge things in that. And then of course we have Tesla, who's building gigafactories. I think he's up to 11 now, I think the last time, if anybody knows, and which are giant plants. So I had the honor of driving my Toyota Mirai with my wife to the grand opening of the gigafactory. They took us in buses to one end of it. It was exactly 14% built at the time. And it took us almost an hour to walk back through the bottom floor. We didn't even see the 2 other floors. Huge, massive facility with thousands of robots and obviously some people. And that's one concept to lower cost per unit. But Catherine came up with an idea that I thought was just absolutely brilliant, particularly when we talk about the third world. So Simplified Battery Company makes a battery. The battery cells are about the size of, a little smaller than my finger. And basically what happens in that battery is they are integrated together into a package with a positive pole and a negative pole, and typically a primitive BMS in the system. And then they're encased in a plastic shell with a cap. This is not high tech. So what Catherine said was, what's the opposite of the gigafactory? Why couldn't we take a bunch of these parts out to a rural village, train the people to assemble them, how to test them, and then leave the first 100 batteries or 200 batteries in the village? Okay, why do you want to leave the batteries? You want to leave the batteries so that they can live through all of the problems that come from mistakes, so that they learn how to troubleshoot the batteries and why it's so important to do step 1 the way it is, step 2 the way it is. And then extrapolate on that to have a truck go to the village, drop off a bunch of parts, come back a week later, and what you're doing is building a series of cottage industries where individual people are assembling the battery, testing the battery, and then they get paid to assemble that battery. And so instead of building 1 million batteries in one building, put 1 million people to work. And I thought that was just brilliant.
Thank you. Do you have a slide? Yes. Perfect.
So thank you, and thank you for inviting me. About 10 years ago, I had a sabbatical. This is since the dean is here. And I said, look, I got to go do something different, So I did a lot of time traveling, and I realized that, I was always looking at a problem with, what is it that I knew? I said, let me set that aside and focus on what I think is the problem. And it may require different skills, different knowledge, so it's a little bit of that journey in your last phase of your career, right? So that's what I want to talk about. And so here's some thought. This was to go dive in. This was in this part of Uganda, working with a local quote-unquote cooperative. We talked to quite a bit of people there, and I would just summarize what I learned there. Talking to people, they said, we want electricity, when we want it, in the amount that we want, and only pay for what we use. And I'm like, wait a minute, after all the research, it's actually pretty simple, and that's what we do. We also can use something whenever we want, in whatever amount we want, etc. So, the grid was not there, so we said, let's do a pilot, and we installed these 8 mini grids there. We fully, it was fully kept it digital so that we can have the data and understand all that. So typically they were small. We concluded that wire more than 100 meters would actually be cost prohibitive for the co-op. It was absolutely essential that it was pay as you go, because payment systems otherwise were, they said, look, the financial management won't work. So they were pay as you go. And by the way, we started with the most complicated beast, and over the years it's been simplified. So it's opposite of making complicated with time. We started with actually payment systems tied to cell phones, the disruption of even SMSs and all. Today, these mini grids are running even if there is no data connectivity in the back. So they were very small to start with. I'll tell you what happened later. We used, at that time, some expensive smart meters. We have gone much cheaper now. And, to me, this is not a solar system. On a cost of ownership basis, this is a battery system. We tried diesel. Our first mini grid was diesel. The problem was not CO2 emissions. The problem was actually financial management. Okay, so just so it's much easier. So my lesson that I came from there was after this is that actually fewer people involved in operation was better, which is counterintuitive. You'd think that in a low place of labor cost, it should be more people. Actually, as much we removed the people, the functioning was better. And so the only people involvement was through the payment system. And so, I'll come to the financing model later. But what we observed was very, very different from what Jay showed, was very significant growth at the early stage. But the key was that they had tariff financed their initial cost of wire to the home. Not the entire mini grid, but initial cost of wire to the home and the internal wiring. Now in 2017, or now 2018, it's down to 50 cents and $1. And my rough rule of thumb, I concluded after looking all this data was, these people spend about $4 or $5 a month. If the electricity is 50 cents, they'll buy 10 units. If electricity is $5, which is what it was on solar home systems 8 years ago, they used a kilowatt hour. So, they were constrained by other things on how much they spend. But I think the key lesson here was to finance the upfront cost that the energy cooperative was not willing to do. Same thing as appliances, right? So they had no cash, but they were able to pay this recurrent cost. Over time, the growth in some of the grids, and I'll come to that, out of 8, 5 grew quite a bit. We wouldn't have known which 5 would have grown, right? And that's why countries do electrification, right? They don't know in advance everything, nor do they want to take away the option of growing from people either, right? So that's how China, grew and so on. But there's a neat lesson for incremental infrastructure. When the capacity is full, the operator put another system next to it. So they don't have to put a huge capital out upfront, right? And I think when they put that second solar system, it was very profitable, right? Because they didn't have to now put wire and so on. Now, there was a reliability versus cost trade-off. A community that is poor, so if they had to have 100% reliability, the cost of providing service would have been double if they had 90% reliability. So we settled for 90 to 95% reliability, right? Of course, you can, with digital systems, you can prioritize those who want to pay more or a health clinic. But the point is that when you have a completely off-grid system, that last 10% is expensive. But where the grids are unreliable, people were happy to have this at half the cost, so to speak. Local labor for trenching was very important in keeping the cost of wiring low. Traditional systems were using poles and wire, right? This was still AC, still done to standards. You can see the tape on top, right? To the point that Stone Farm, Craig, made, the slowest part was the concrete, okay? And I'll come to that. And then, we saw a kind of interesting efficiency link. If they had bought this ice-making machine on their own, it would have been inefficient. But by tariff financing, they actually managed the utility to buy an inefficient one, which they paid off over 3 years. So tariff finance can also be a means for efficiency. My still observation is mini-grids provide this ability to grow. So to me, the biggest lesson here is that if I had bought a solar home system, I would have been stuck here. Each time I want to add a machine or a sewing machine or a refrigerator or each thing, I don't want, like I do here in New York, if I go out and buy a bigger refrigerator, I don't have to go out and buy a bigger battery and a bigger solar panel and a bigger inverter. I can just buy the bigger refrigerator. So I think this ability to grow seamlessly is something that the grid provides. So the question is, how can we trade that off to make sure you have some ability to grow, you are grid-like, but at the same time, you may be able to do this for perhaps cheaper than the grid, and I'll come to that. So now, something that emerged was very interesting. Initially, pretty much everybody was a residential domestic customers. but a very few of them really took off and became business customers. It's hard to see the vertical axis, but that's an order of magnitude higher. We wouldn't have known who would be those few who would really grow, right? Now, as growth occurred, but this is just, there's a industrial engineering operations research student who even did a thesis. We have a kind of daily energy and power limit on each circuit. So you kind of are spreading out the lack of reliability. So how do you prioritize someone's supply? So for example, if a kid, so we'll realize that if a kid, to just make it kind of real, if a kid is studying every night from midnight to 1 regularly, if that load is predictable, then that capacity is reserved for that kid, so to speak, in the algorithm, right? So it's a very simple way to allocate capacity when you are short of capacity. I mean, there's a whole lot of math that goes around it, but you have to finally fit it all into a small Arduino or Raspberry Pi for control. Now we learned the biggest lesson was modularity, time of execution. So we learned that from IKEA, right? IKEA makes it cookie cutter, so there's no concrete here for Craig's, right? All the parts, the tools are actually in the kit, right? And the assembly is done locally also, right? So I think learning a little bit of things like what can you, so the example, what can be, right? Then move on to some mini grids we have deployed without storage, because storage is still, I applaud all the work that chemical engineers are doing to make this work, but cost is still, the driver here. So we saw a big opportunity for agriculture, where water is in effect a means of storage, right? So, we went, this is in Senegal, hand irrigated onions and so on. So, but the farmers are small. The farmers are small. How could we deploy a super low cost grid which doesn't have storage? So, because the farms are small, we deployed a mini grid for multiple farmers, which is driven by a variable frequency drive, which allows small AC motors to come on easily. And these are the kind of pumps. They are submersible pumps. They are dirt cheap compared to DC pumps. Cost was really my line is cost is not important. Cost is the only thing here when you are dealing with the poor, right? So then, the pumps come on as the sunshine comes on, right? So one pump comes on, then 2, then 3. So you try to fully utilize the solar, and the water is prepaid to this person sitting on the left in the morning. And really the key is the variable frequency drive. I was actually shocked that one can make those for 1/10 the cost of an inverter, and they're actually better than an inverter in some sense because they're able to handle the motor loads, right? But I wanted to say that, it's not just energy. You need other things. You need roads to transport it. You need a market and all that. So, I think we have to follow the demand rather than we saying everything will be solved by energy alone. I think financial management was, I thought, the key lesson I learned, that our technology should recognize the importance for it, allow for it, design for it, train for it, and make sure that is because that's what the community wanted. That's what the co-op wanted, right? Training in. See, the other thing that's changing is, people are used to making an oil change on an engine, right? But the new stuff is actually uploading a new software. Or, my plane was late last night because they had to reboot the power on the entire plane to get a computer to work, right? So it's training in software and digital systems that is going to be an important part of the new thing. I'm just, we are modularizing and sort of making some of the systems very compact. So this is sort of like a bread box size that allows customers to interact, demand supply management, battery management, payment management, all occurs inside one box using NFC cards. And these have been installed in the field. And we are finding that kind of keeping everything like what was also a lunchtime talk, right? Keeping all the smartness kind of small, compact, modular is key. We are still not getting to this place where the grid connection arrived, and this is still hard with these small mini grids. And so how to design the variable frequency drives that can do that, or that's still an issue. I think we feel the need in Africa for creating local testing labs so that appliances can be tested locally, because otherwise all sorts of shoddy product is showing up. And then finally, to a question that Jay brought up, where is the distinction between a mini grid and an off grid? So if we studied the data for household patterns in 10 countries, now on the vertical axis is the amount of medium voltage wire per household, which is at a higher cost than the kind of low voltage wire. And inter-household distance is a metric of low voltage wire, which, as I showed you, can be trenched, etc., and much lower cost per meter. So this can be less than $5 a meter. This is $20 a meter. So if you have communities that are very far apart, like we have in Mali, Senegal, Tanzania, but compact by having inter-household distance low, then in this quadrangle is when mini-grid viability is higher. This actually image is from Ethiopia, right? So, and each of the dot is a home. So I think we are beginning to think about quantified metrics that can allow us to really say easily what's where. At the end, so far my observation, and these are all rough numbers, they're all ranges really, and I think Jay already alluded to it. To me, mini-grid low cost is a pathway to something else bigger as time grows. I am almost certain. I grew up in India with somebody carrying an engine and a motor on their head to go take that to their farm to irrigate. I think growth will occur, right? So how to design so that you can have that growth, but the countries can address their capital cost challenge. And the last thing I want to say is, it's easy to do something that is completely private. There's a business. It's easy for governments to do that is completely public, which they just fund everything like they do for the grid. But it's hard to do the mix of public and private. And I think that finding good models for that is going to be important, because I still don't think that a very poor person is able to pay for the infrastructure that creates the opportunity for growth for them. They can pay the recurrent cost. They can save the money to replace the batteries. They can save the money to replace the inverters. They did that through the tariffs. But I don't think they would have been fully able to bear the upfront costs, so business models are tricky. I'm going to stop there, but thank you. Yeah.
Good. Thank you all three for sharing your experiences. So now I'm gonna ask some questions, and then for sure we'll have also time for open questions from the floor. I guess we've already mentioned some of these, but microgrids certainly in a developing context will look quite different than the microgrids that we were hearing about in the morning, or especially the microgrid that we heard about at lunch, where the financial constraints, the budget considerations are much more pressing, and the willingness to pay is still very limited, in part because people don't know how much is their willingness to pay even. So if you had to highlight one big difference between where microgrids are going, for example, in the US, and where microgrids are going in a developing context, what would be that one difference? I know this is a hard question, so feel free to put 2 or 3 differences. But what would be the major differences, not just on how they look like today, but the trends you see in this type of microgrids?
For me, I think microgrids in the US context has a lot about sustainability, resilience, and creating a model for the future. For the very poor, I think they want higher incomes. So whatever leads to higher incomes and is of course great. So if you can plant an extra crop and make, onions in Senegal are like $100 a ton, and you can grow 20 tons of that, that's $2,000 of product, right? That's very high to me. And the second is, they can save money to some degree by substituting kerosene, candles also. So that's also a saving, better quality of life.
So another highlight I'd say is modularity, being able to grow systems. So there is a lot of unpredictability about which customers are going to emerge into being those that grow into the ability to consume more. And Vijay was saying earlier that they had 5 of 8 grids grow, but they weren't sure which 5 those were going to be in advance. They weren't sure which customers those were going to be in advance. So as a kind of core primitive of how mini grids are built in a developing context, it's really critical to be able to add modules, add growth, add inverter capacity, add solar capacity, add battery capacity as needed in order to kind of not stifle that growth and be able to stay up with what economies and incomes require. I think in a developed context, much like what Craig had said earlier, is there's a lot more kind of pre-hoc modeling and trying to understand what consumption patterns are likely to be and how electricity is being used in that setting already. That's a much harder thing to do when customers have never had electricity before, so you can't necessarily model those things in advance.
Well, I would say both these gentlemen have a lot more experience in this end of the subject than I do. But that was exactly one of our problems when we were modeling for India was let's say that this container has a change machine on the side of it, and you're buying a battery at the size you want for your house. How many of the different size batteries did you put in? Because you never know what the people are going to want. Now you might have some more modularity in there that you could upgrade from a 1 hour battery to a 4 hour battery, and there's a cost delta there. But that upfront capital to do a system of that size is way beyond anything that we're talking about here. It would have to come in through an NGO or something. But the way that you're growing the systems, I think that's just fabulous.
Great. So we wanted to try to identify some of the successes and failures in these microgrids. So I guess I was wondering if you could explain from your particular experiences something that all of a sudden, or maybe this didn't happen, but something all of a sudden enabled a project that was almost about to be killed, and at the same time something that kind of killed a project that was about to happen. I'm not sure if this is something common, but I would imagine many of these microgrids are hard to push through either because of the finance, because of the technical aspects. So I was wondering if you had any experience on either something that just all of a sudden worked or something that all of a sudden got kind of pushed back.
So in my view, the biggest challenge was really this getting to the right mix of public and private. That was the big challenge. The big, to me, other learning was really making systems extremely robust and lean. Lean, so I call it lean infrastructure. It has to be lean. It has to be fixable locally. And I think I had never appreciated the importance of good financial management and how technology can actually help enable that. Right? So way I see it is the ability to pay small amounts of money on a daily basis without transaction cost. Right? It's sort of like the equivalent of I want to today wire transfer money to Eric, because Eric is this really big shot in energy world at Northwestern. Citibank would take $35 to do that. Well, that can't work. When you are giving 10 cents, 20 cents every day, you can't afford to pay even 5%, right? So to me, secure transactions can be done, should be able to be done at the cost of an email. And we all know how much junk mail we get. So it should be cheap to do that securely. India actually is building such the basic architecture to do that. And to do that while maintaining privacy and all that is, interesting. But I think secure, transaction platforms are important.
Yeah, I can only echo that. In East Africa, we've had this emergence of M-Pesa and other mobile money systems. So at this point in time, 90% of Kenyan adults have an M-Pesa account. That is, with their SIM card, they can make mobile payments, which is a totally different story from what we have here. M-Pesa's been around since 2007. Frankly, for them, it's normal. It's so normal, it's getting kind of old. And so there's that enables so many different business models and has really allowed the energy access industry, whether it's solar home or mini grids, to really flower in East Africa. Mobile money is an enormous enabler for this. So examples of successes and failures. An example of success. So there's a company called Power Hive, which is a mini grid company based in Berkeley, really fancy, they have famous people on their board, whatever else. They were kind of flailing, and they were flailing along for a little while. They had grand plans, whatever else. They hired somebody from Kenya Power who could sit on their board and get the right policy in place to allow them to build tens of mini grids in Western Kenya. Getting that policy across the line, now they're able to eventually get their grids connected to their mini grids connected to the grid when the grid arrives. They have the right policy in place for that, and they're the only mini grid operator that has that in Kenya, and they've been able to start building and really grow their plans and actually start to achieve some of their grander vision. So the policy is pretty important there. Examples of failures. So two particular ones come to mind. So there's a company called Vulcan. Vulcan is Paul Allen's, from Microsoft, Paul Allen's investment / big ideas company, and they look at how to kind of bootstrap new industries. So Vulcan invested in a set of mini grids to kind of build learnings and try and grow. At some point, they decided they'd learned enough, and they've been trying to sell those mini grids for a long, long time. Nobody's buying. The same thing has happened with, I forget the name of the company, but they run about they run about 75 mini grids in Rwanda. It's another company.
They want to get out.
They do want to get out.
Yeah. And if you want to buy it,
yeah, ready. If anybody wants a fleet of mini grids in Rwanda, 2,000 customers, small mini grids. But the point is that the kind of uncertainty that comes around these mini grids, not knowing when the grid's going to come, not knowing how demand is going to develop, things like that destroys these business models. And so there's a lot of uncertainty still in the mini grid space that's important to start to quantify and parse, but that tends to be something that sinks a lot of these business models.
I'm going to go along with that. So I have an employee who goes every year on a medical mission for 2 weeks to Africa, and Uganda is where they were last time. So they were traveling with a group of doctors, and he was sort of the technician with the group. And they get to a hospital, and an NGO had a few years ago donated a diesel generator, a battery system, and solar power to power this hospital. Well, the system didn't work when he got there. So I think it's a perfect example of us dropping technologies into places where we are not also dropping the education. And so these models have got to walk hand in hand with an educational structure. So in the India scenario that we were talking about, where we were looking at these containers or the carry-in device, part of the concept that the interns came up with was initially the device would be taken in, sat down with trained personnel supplied by the company, who would train 10 people on the operation of that device. You got to figure out how to train the trainers. And out of 10 people, you're likely to get 2 or 3 who understand the concept and can be then skilled a little more to become the trainers to drop in with the next device. And how you clone that. So failure is easy. I can tell you on our project, we've learned to fail really well. Successes are much harder, especially in these smaller systems, because they're going to be twitchy. Somebody comes in and takes too much demand in a given period of time, it can crash the whole system. So, I can't even imagine, how you deal with that. But that's sort of an example of failure. And I really don't know of a good example of a success of that. and it's probably my ignorance.
Well, I can tell you this is a low-cost $30 smart meter that we got built and we have installed. Tracks and provides an energy limit for each circuit and a power limit for each circuit. That was essential, right? Otherwise, one person's taking more power can disrupt others, right? So I think individual circuit level energy and power limits were very important.
Well, and let me make a comment on that, because I'm very aware of what it costs to buy a smart meter here. And
It cannot be that. It
right,
has to be
it's-
1 0 less.
That's right. Well, and most of them are in the $6,000 range. If you're integrating with Cal.
No, then it is 2 zeros
That's
less.
right, it's 2 zeros less. There's magnitudes here. So coming up with a $30 smart meter is a technological leap.
It can
That's
be
a light
done.
year.
I don't think that's hard.
Yeah.
It's already done.
That's
already
what,
done.
this is what has to be done. We have to have big, bold ideas.
Great. So I think we want to make sure that there's some room for questions. I guess I wanted to ask one final question before passing the baton to the audience. It's about reliability. So obviously reliability in a developing context, it's a much different bar, I would say, than what we would demand, for example, here in the US. So what's your experience interacting with the final end customers? How much do they value reliability versus having electricity at some point that maybe they did not even have access to before?
In my view is, the mini grids were hugely more reliable than the grid, but also as long as you have predictable unreliability, right? So what we found is that if 2-3 days in a row it's cloudy, right, then you know that your battery has less charge. It was better to cut down everybody's power limit and energy limit that time so that at least you can continue to do 1 light out of 3 lights. You can still charge your cell phone. You might have to unplug your refrigerator, right? So you leave that flexibility where you don't have to shut off everybody completely. But that saves huge cost. If you wanted to continue providing service through that event, it would have been more expensive.
I mean, people can plan for predictable unreliability, but it's these challenges on the grid where some fault happens and you have no concept that it's likely to happen. You have no concept of when it's likely to be fixed. So I've been studying grid reliability for a long time, and still in large cities. So Nairobi has 8,000 outages a month, and they're different parts of the city, different sizes, whatever else, but people have a sense that, hey, when it's going to rain, there's going to be more power outages. The data don't bear that out, but at the same time, there's a very different experience with reliability when it's something that you can predict, something you can see coming, versus something that is just unknown to you, and then you stop depending on that electricity source as being something you can use and weave into your life and your activities. So my experience is the same with Vijay. I think that mini grids tend to have much more reliability than grid systems. Solar home systems are often in the same boat. Tends to be much more reliable. You're not depending on as much interconnection, as many kind of components you're not aware of physically.
So if I might kind of move your question slightly and ask a question that I'm really curious about it. And so in that mini grid model, are there rules? And so when I say rules, let's say one of your clients in the system decides to put microinverters and solar panels on their own house, but integrated with your grid.
Can't be done. You can't allow reverse flow in this low-cost systems, right? By then you have to have sophisticated inverters and all that, right? So not in these. These are, remember, at the end of the day, the power level allocated on average per customer is like 100, 200 watts. Not like my home in New York, I have a 200 amp connection, right? That's 20 kilowatt, right? So these are 200 watt systems. So when we did the pumps, yes, we had to allow for the surge current. But again, for that, we had to go to variable frequency drives so that you don't have the high surges. Otherwise, an inverter cost would be through the roof,
In rush.
Yeah.
That's
Exactly.
that's what I was wondering, because
Right.
there you've got it's sort of a semi-governmental agency, and how do you build the rules so that everybody plays on the same field?
Correct. So I think that, induction motors are still pretty robust and can take a lot, and coupled with a VFD, they do a lot. Right? So.
Yeah, and I should mention that on our grid, if we go to our smallest battery inverter system, and Jorge has proven this I don't know how many times, that if we curtail the use or load shed our inductive motors, these are primarily well pumps or pressure pumps, we can actually start our grid in a limited form on a 30 kW inverter and the Aqueon batteries. But I don't know how many times we've proved that if we have one pump start up during that process, that inrush current just crushes everything and you're back to blackness.
So let's take some questions from the floor. Yes, first.
So I was really interested in the contrast between Jay and DJ over, provision, supply of electricity, and then either kind of flat consumption or rising consumption. And I just wanted to get the two of you to reflect a little bit more on on the uncertainty over what people are going to do with power once it's supplied. And because in my mind, and this is just a sort of off the top, one idea for like a household would be, with a limited supply of electricity, you prioritize, and you decide, okay, I'm going to consume for my, I need some power for my refrigerator, my cell phones, my water pump, but not for my stereo, right? But if there's a little more supply, then, so there's a kind of a preference ordering of items in the household, and that you could use some theory like that to kind of say, when you supply electricity, here's what people are going to do with it. And given that you both have such disparate findings, I'm wondering if you could say a little bit more about what model of household power consumption you have that kind of shapes your expectations about what can happen once people plug into a microgrid.
You want to go first?
Sure.
You want to go first?
Sure. So my sense is that it's seldom that electricity is what shortens supply. It's often money. And so, like Vijay said, you commonly have a budget. You'll see different prices. You'll see roughly the same consumption in currency, dollars or shillings or whatever unit. And that's a pretty important finding. So one of the kind of things that underlies our hypothesis around appliance financing is that if you can just provide a little bit of that capital up front, you might be able to open up a different avenue, and particularly on for grid customers. Grid electricity, especially in that lowest tier, so it's usually a progressive block tariff. That lowest tier grid electricity is anywhere between like 2 and 10 cents a kilowatt hour, extremely cheap. So, and people are leaving a lot of that available and not consuming it. So it's not necessarily a limitation of electricity. It's not necessarily, it's getting that money up front. Now, as far as kind of preference orders and things like that, people take care of those. You absolutely need to let people take care of these things on their own and kind of not program them into systems in any way. People walk with their feet. They will purchase if the price is reasonable. They will consume if they have the resources and it provides value to them. I think that when we were coming up with this study and trying to understand how we might actually get appliances into people's hands, we were thinking about, well, what set of appliances should we offer? And we ended up with a very large set. We also ended up particularly by including televisions. And you always hear this debate around productive uses. Should televisions be included? Well, no, that's not necessarily productive. You don't see a business that comes out of that. That's what people want. And if people are willing to pay for that, who am I or who is anybody else to stand in front of that? And frankly, for these businesses, if people are going to, electricity serving businesses, if people are going to purchase televisions, pay those back, and purchase electricity with it, then great, more power to them, literally.
Well, only thing I want to add, so very much agree with that. Only thing I can add is we did a survey of about 300 homes in 10 communities about 10 years ago. And what I was shocked at is the tremendous heterogeneity in income, even in a poor setting. So there's a huge amount of heterogeneity. And so I think that allowing for growth within limits so that then you can add incremental infrastructure. Not everywhere that same growth will occur. So if in 5 out of 8, you can add that incremental thing. Right? And I think that, so that's one. And the second thing is that how can this information be absorbed by the utilities so that, and by the way, that growth had a lot to do with few people consuming a lot, right? How can that be picked up and sensed by the utilities so that they can actually come and make more investments there? Because at the end of the day, I think the big difference I see is China kind of did it everywhere. They had a unique financial model worth studying, and we could spend an hour on that, but they just did it everywhere. There was no targeting, right? In India, targeting occurred without intent because some states just didn't keep up with it. Some other states did very well. In fact, by the way, those are the states where the Green Revolution succeeded, right? Whereas if you are very resource constrained, you are forced to prioritize, right? So how can you get the signal of prioritization?
I have a question about these populations in which cash flow may be problematic, not only availability, but availability that changes over time, right? If I'm a farmer, until I have my harvest and can sell the harvest, I have no income. So to what extent are people afraid of joining into this because they will think, well, if I'm going to buy in and I have to pay every month, then there will be those months in which I have no money.
Totally agree. Totally agree. In fact, I personally observed that there should be no upfront cost. And let the recurrent cost, let the farmer or household, let them adapt to their own variability of income. If I show that curve of growth, you will see the seasonality in that, right? But trying to get upfront cost out of someone, I think, defeats the purpose of, yeah? They are fine, absolutely. That is allowed, right? You only pay for what you use is the lesson we learned. Don't have any flat fees. That no matter, and that's how the cell phone model grew in India. They tried the model, $10 a month was linear growth. They said you only pay by the minutes you use, exponential growth.
And I can echo that. Kenya Power is learning this lesson right now. They're switching from a fixed fee plus a variable fee to a purely variable fee because of exactly this experience. So many people that recently were connected would just accrue those fixed fees and not be able to pay them off. And also there was a little bit of opacity about, why do I have this bill now? Why do I have this bill now? And it absolutely limits consumption and limits growth in consumption.
Great, perfect. So we'll have a break now, yes?
Nicely done, guys.
Yeah, great report.